Hi folks, in this second part of the lesson we're going to take up parts 4, 5, and 6 of the investigation. Okay, so here I told you to take some tools and to show that one radian was the same regardless of the size of the circle, because that was one of the concerns we had. Okay, so here what I did is I did one of them here, so I just sort of took my string, okay, figured out what the radius was, and then try to create that arc. Okay, and I measured it, and it turned out it was about 60 degrees. It was pretty close. Okay, so we'll call it 60. It's a nice number. So let's see what happens with this larger circle here. So, again, you might have thought of putting a little dot on your string, okay, to figure out where the length of the radius was. So here, there you go. I measured that dot already from the radius. Okay, so let's draw that line. All right, and let's use our protractor to see how big this one is. Okay, so I see this one here looks to be about, okay, just over, looks to be about 56 degrees. Okay, now question is, why didn't we get 60? Well, certainly anytime we're doing anything by hand, anytime we're doing an experiment like this, we're going to have some error, so maybe I was a little less careful in one. And the question is it actually 60 degrees? Because when you think about it, that would be really nice, okay? Because then that would mean, 60 degrees when you think about how many radians are one full turn of the circle. Well, we can sort of figure that out, okay? Now, how you did question B. So, in terms of the first part, okay, because they're really close, I'm actually pretty convinced, and hopefully you found something again somewhere in that ballpark for the third circle, okay? But again, not exactly the same answer, but in the same ballpark. So let's look at B. It says use the tools to determine how many radians there are in one turn of the circle. So I mean, if you followed the rules explicitly, you would have used your string, and perhaps you might have, taken this here and used your string and figure out how many, radii, which produce, exactly one radian each time, okay, to get the full circle. And I did that, and again, it turned out to be about 6 times. Okay, so my estimate here would be about 6 radians to go around the circle. Okay, clearly this one here, I'm going to get more than 6 radians to go around the circle, since my original measure was a little smaller. Okay, so again, the question is it actually 6 radians, or is it a little more, or maybe some other mistakes, maybe it's even a little less. Okay. Now, having said that, you might have decided not to use the tools. You might have decided to use some algebra to do this here. So for example, if you know what the radius is going to be, okay, and you know that each radian, okay, produces this arc of whatever the radius is, you might have said, hey, I know how to calculate the whole circumference of the circle, okay, and then I could have just divided by the radius. Well, that's what we're going to do to show this analytically, okay, because essentially what were we trying to do here is we were trying to determine how many radii go into this circumference, okay. So in other words, you were essentially calculating the circumference divided by the radius, okay. That would be the angle around the whole circle, because each radian, okay, represents 1 radii, so you want to know how many radii does it take to go around the circle. And of course you can determine how many times bigger something is by doing a division, okay. But we have a formula for the circumference of the circle, which of course is 2 pi r, okay, and when I divide that by r, look at what happens, okay. We're just left with 2 pi. Okay. Now we've seen this before, where we can solve a problem not necessarily knowing the exact size of the thing we're working with. In this case here, it doesn't matter what the radius of the circle is. okay, it's always going to take 2 pi radians to go around. Now, 2 pi radians, that's about 6.28. Okay, so it turns out that probably our measure here for a radian was a little better than the one for the medium circle. Okay, so now we've got a very important discovery here, because we have a way to relate radians to degrees. And that's what I asked you to do in part 6. Because if I know that it takes 2 pi radians to go around a circle, well, I know that it takes 360 degrees to go around a circle. And so this is our relationship between degrees and radians. Okay, and you might say, well, we're working in one or the other, but often, we know that degrees are still in heavy use. So if we're given some information in degrees, it might be useful to convert it into radians. Or because we have a sense of what degrees represent, I might get an answer in radians, and I might want to convert it into degrees to get a physical sense of how big that is, because we're used to working. If I say 30 degrees, you can picture that in your head. Okay, now we actually write this relationship in a slightly simpler way, because if 2 pi radians is 360 degrees, well, then we know that pi radians must be equal to 180 degrees. Okay, and so this is the relationship we use to go back and forth between degrees and radians. Okay, so let's see how we can use that. Okay, if pi radians is 180 degrees, well, I might want to know what 1 radian is equal to. Okay, so that means I'd have to divide both sides of the equation by pi. So pi divided by pi gives me 1 radian, so I'd have to divide 180 degrees by pi. Okay, and so 1 radian in degrees is 180 over pi, or I might want to figure out how much 1 degree is in radians. Okay, again here I'd have to divide both sides of this equality by 180, so 1 degree would be pi over 180 degrees. Okay, so let's take a look at these numbers, and I think they make sense, because a degree is much, much smaller than a radian. I mean, look here, 1 radian has this size here. 1 degree, remember you're splitting up the circle into 360 parts, would be something much, much smaller. So it makes sense that. So one thing to keep in mind if you're trying to remember which is which, well, 180 over pi is a much bigger number than pi over 180. So this must represent a degree, that must represent a radian. Okay, so let's now use this to answer the questions. So if I want to write 50 degrees in radians, well, I know that each degree is equal to pi over 180 radians. So here I just have to do 50 times pi over 180. This gives me the answer in radians. And so here we've got, well, 50 over 180, that can simplify to 5 over 18. So we say it's 5 pi over 18 radians. Okay, and you're noticing here how, and you will see as we go along, that when we're talking about radians, the number pi will often appear if we want an exact answer. Okay, certainly you can put this in your calculator to get an estimate. Okay, so let's do it the other way around. If I want to figure out how much 2.5 radians is in degrees, well, again, each radian is 180 over pi degrees, so it's going to be 2.5 times 180 over pi. Okay, and so here 2 times 180 is 360 plus another 180, which is half of that. 2 times 180 is 360, and half of 180 is 90, so 360 plus 90 is going to be 450 over pi degrees. Okay, and again, quite a large number, but that's not surprising because 1 radian is much bigger than a degree. Now, let's say you don't remember these, sort of you're just having an issue not remembering which is which and you can't figure it out. You can also solve this using ratios. Okay, you can sort of say, well, if I'm looking to figure out what 50 degrees is, I know that there's pi radians to 180 degrees, and so I want to know how many radians there are in 50 degrees. Okay, so solve this using a proportion, and so here x is just equal to 50 times pi over 180. which is exactly what we had originally. Okay, so let's just recap here. So number one, our definition for a radian, while it does involve talking about the radius of a circle, doesn't actually depend on how big the circle is. Okay. Next important thing we discovered is that to go all the way around a circle is exactly 2 pi radians. Okay, and because we know that going around a circle is 2 pi radians, we have a way to relate radians in degrees, that pi radians is equal to 180 degrees, and we can then use that to convert back and forth between those two. Okay, so last part is I'm going to think about number 7, and then we'll take that up in a bit.